10. Shall we start with 1 through 10? All right, so look, your calculator's key on this. In fact, everything we're doing in this first half of this chapter is calculator reliant. What? What do you mean? Oh, y'all hold on one second. The fit what? Well, that's only when you get your stat plot on. I'm going to start with, I'm going to start with K through T. See what I'm talking about? Yes, Miss McGee, we see what you're talking about. Okay. Are y'all so tired too? I'm just so tired. Okay. So the first thing I want to do, and I helped several of you with this yesterday, my advice here would be, the first thing I would do, maybe Jackson, you're talking about adjusting the window, maybe? X squared plus X. So I'm going to type X squared plus X in here for Y1. If you don't have something entered in Y1, your table's not going to work. You have to have an equation entered in there, okay? And the very first thing I'm going to do is I'm going to say, okay, for 1 through 10, which one of these T-charts match this equation? So to do that, I'm going to go into my T-chart, second graph, and I'm going to actually look. Maybe y'all can see that a little better. And I'm going to see which one has those same points. So if you look at number one starts with the point 36, right? Do you see that in your T-chart there? So I'm going to enter a 3 and see if I get a 6 back out for Y, and I don't. So I know it can't be number 1. So then I go to number 2, and I put 0. I don't get 2, because you see on number 2 is 0, 2, right? 3 is 2, 4, so I'm going to go back to my calculator. I'm going to put a 2 and see if I get 4. You see what I'm doing there? Okay, if it doesn't let you, yeah, you got it. Oh, Law, Miss Goodwin said make sure you check your email. She sent me a text. Second window. Wait, so her husband is the. Do you see where mine's on independent? It should say, you should need to highlight ask and hit enter. So make sure it says hello. You see what I'm saying? And then now go back to second graph into that table. And it should allow you to input those values now. Yes. So that didn't work, right? So I'm going to keep going through the ones to see 5. I got 30, not 20. I mean, not 90. 1, I get 2 and not 39. 1, 5, no. 5, do I get 1? Nope. 4, do I get 20? There, that one works. So that's number 8. See this number 8 here? See, it's the X is 4, the Y is 20. That one actually worked on here. So you can check the rest of them if you want. Does 8 give you 72? It does. Does 12 give you 156? And it does. So that's the one that matches. So now I know that number 8 goes with K. Now I need to find the graph that matches it. So what I would do here is I'd say, okay, clearly this is a quadratic, and we know what quadratics look like, right? These are parabolas that open up. Well, if you look at your graphs here, this one's not a parabola, this one's not a parabola. This looks like a square root graph. Linear, that's a parabola, but it's opening down. It might be F, or it could be I or J. So here's what I'm going to do. I'm going to start with F, and I'm going to take my calculator, and whenever I graph it, if I can get it all in here, see how this tells me that the window for F, the window from F goes from -1 to 7 and -4 to 40. I'm going to hit the window button on my calculator, and I'm going to take X from -1 to 7, -1 to 7, and then I'm going to take my Y from -4 to 40, and I'm going to hit graph. Does that look exactly like the one in the book? Does this and this look exactly alike? No, right? So it can't be F. The first one's going to be the hardest because you're eliminating choices as you go. You're only going to use everything one time. So once you use it, mark it out. All right, then I'm going to try I. So I'm going to go back to my window, and I'm going to go from -3 to 9, and then from -2 to 60. Graph. This one looks better, but it's still lacking a little bit. If you look at this one in the book, how it's dipping down below a little bit, this one's not. So now I'm going to try J. -5 to 40. This is really just getting you back used to using your calculator. To 650, graph that. This one does look like the graph. These look like they match. So I would say number 8 is both K and J. Mark out K, mark out J, you've already used them. Every equation will have one table and one graph that goes with it. Does that make more sense? Seeing it like that? If you started with the tables, it's a whole lot harder because you have to put them in stat plot and all. Yes or no? You'll have to speak up. Okay. What else on your homework? I heard 13 and 17. 13, model the data graphically with two scatter plots on the same graph, one showing the percentage of women employed as a function of time, the other showing for men. Measure the time in years since 54. So that's important too, because on your table here it says 1954. So if your X is years since 54, then what would 54 be? 0. What would 59 be? How many years since 1954 is 1959? 5. This one would be, how many years since 1954 is 1964? 10. And I bet you can see the pattern as you go. That's right. So what I'm going to do, I'm going to take my calculator, and I'm going to input these values. My arm keeps hitting it. All right, remember how we do this? Do y'all remember? What do I go to first? Stat. Edit. And I'm going to show you, I'll show you a little trick with this too, to get all this in one time. But here we go. Oh, I'd already put this in, hadn't I? No, I hadn't. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So I need to go up to 50. I'll get 25, 35, 40, 45, 50. Everybody sees what we did there? All right, in list 2, I'm going to put the female here. So 32.3, 35.1, 36.9, this is the most time consuming, is just entering all the data in there and entering it correctly. While I'm in this screen, you see how I have list 3 over here? I'm going to go ahead and scroll over, and I'll show you why in just a minute. And I'm going to input the male stuff there in list 3. So I'm going to do 83.5, 82.3, 80.9. Y'all tell me when you're caught up with me. Now, so this said to model graphically with two scatter plots on the same graph, and I want to show you how we can do that on the same one. And all you're going to need to do is do it on your calculator, and then you can just sketch it on your paper. It doesn't have to be exact. But remember we went into that stat plot, so do second y equals. And I'm going to graph them both at the same time. For the first one, I'm going to turn it on. And remember, I need my x to be list 1 and my y to be list 2, right? That's where I put the female data. Remember that? So I'm going to turn that on. Now what I'm going to do is I'm going to go back to second y equals, and I'm going to go to plot number 2. I'm going to hit enter. I'm going to turn it on, but instead of list 2 for my y, what do you think I'm going to put? Where did I enter the male data? List 3. So if you look right under the number 3, if you hit second 3, that'll pull up list 3 right there for you. And I'm going to make those dots look a little bit different. Remember I told you this was just to how they look? I'm going to remember that the women are going to be square, the men are going to be the plus sign. And now I'm going to zoom stat. And it should plot them both on here for me. So zoom 9. And there they are. Which one were these? The women. Which one were these? The men. Does that make sense to you? Okay, so in your second y equals, you've got both of your plots on, plot 1 and plot 2. You got list 1, list 2, and list 1, list 3. Hit zoom 9. It looks pretty cool though, right? I think that's cool. What do you mean? By hand? You could have. So if you're in your stat plot here, come down, see where it says Y. Whenever you scroll down there, hit second and then the number 3. Because if you look right above number 3, it says L3 in yellow. Any other questions about that one? That's all you had to do was plot them on the same graph. Yeah. You only have what? Did you turn your second plot on too? Hit second y equals. When you're in second y equals, these should both, the first two should say on like this. My graph, there's my graph. Everybody okay? Carter asked, could you do it by hand? It is a lot to remember. It's the stat function does a lot of different stuff. You don't have to input if you're just looking at trends. You could graph this by hand. If you're not quite as accurate in your graphing, it causes some issues. The biggest thing here is whenever we need to calculate a regression equation. Remember yesterday we talked about like the line of best fit for the data? It's easier just to have that calculator do that for you. All right, what else? Yes. 17, are we using the same? We're using the same data. What? Oh, hit y equals and clear that out, and then hit graph. It didn't work? Okay. 17 says if the percentage continues to follow the linear models you found in exercise 15. So I'm assuming in exercise 15 you went through the regression. Is that right? Yes, no, maybe so. Yes. Okay, so 15 says to model the data algebraically with linear equations of the form y equals mx plus b. And then it says to write one equation for women and another equation for men and use the 1954 and 1999 data to compute the slopes. Well, in 1954, so I've got men and women, so I'm looking for two equations, right? They're right, because that's right. All right, 54 men, what was the employment statistic? I think you're doing the slope. Actually, female first. I'm finding the 2 points here that it's told me to use, 58.5. Because essentially all you're doing is writing the equation of a line given 2 points. Nope. Are y'all following what I'm saying? Or are you just... All right, who said no? You probably are not, Carter, because you're doing something else. Oh. Okay, so 15 asked us to model it algebraically with the equations, and it said to use the 1954 and 1999 points to compute. Okay, how do we write the equation of a line? We first find the what? The slope. The slope here is going to be, I'm going to subtract, right? 58.5 minus 32.3 divided by 1999 minus 1954. Does that confuse anybody? Were you confused? So remember, slope is rise over run, or y2 minus y1 over x2 minus x1. So first I'm just focusing on these 2 points right now. Then I'll move on to the next two. So up top, I get 26.2. On the bottom, 45. So my slope is approximately that's fine, because that's what I showed you yesterday. It should be close. Yeah, you're close. That's fine. That's fine. Now to write the equation of a line, I'm going to use point slope form, right? I've got a point. You can choose either one of those two that you want to, and the slope. I'm going to finish this one, and then I'm going to let them do one and all. But that's not, you're good. That's not what they asked me to do, right? They asked me to put it in slope-intercept form. So how do you get it to slope-intercept form? So tell them what you did, Aiden, because that might be easier for everybody. This is by hand, so this is Carter's way because he wanted to do everything by hand. If you have already put all this into your calculator, right? You've already loaded all that data, list 1, list 2, list 3. Go stat calculate number 4, right? And hit enter. Now, when you hit enter, and I didn't tell y'all this yesterday, this is just list 1 and list 2. But it gives you the A and B. It's already in slope-intercept form. 0.567x plus 32.45. For what x? You don't have to do anything else with that right now. That's all. They just want the equation for this one. Now, I will tell you that if you want to do it for another list, you can follow it with the two lists, the x and the y. So I can say, okay, now do the same thing, but calculate it. I'm going to calculate for the min now. If you follow it that way, it'll calculate for those two. And then you got your slope-intercept. All right, I'm going to give y'all just a second because I want y'all to do the equation, the next one. Use your equations to do that next one there, the one you asked me about, 17. In other words, finish what you were supposed to do. Ivan, I'm not sure. I don't know. All right, so 24 is exactly the same as what we just did. So it says to form a scatter plot. So we're going to take out our trusty calculator yet again, and I'm going to enter all of this data. The difference is here, this is 2 columns of data, but it's the same stuff. It's just a continuation. So type it all in. Y'all need me to do this one for real? Huh? What's wrong with it? Oh, I thought you were saying you couldn't see it. I was like, why? Y'all need me to put all this in? If you don't need it, I'm not going to do it. So this one, here's all your data, right? I'm going to go into stat edit, and in list 1, I'm putting the year. And in list 2, these are the numbers that I'm inputting. Right? No, are you okay? Are y'all okay with that? Okay, so once you put it in your calculator, the equation part, once you put it in your calculator, whatever the data is that you have in your calculator, here's what you're going to do. So write this down if you're having trouble with the equations, okay? If you go stat and then over to calculate, what you first have to do is whenever you look at the scatter plot, you decide, hey, does this look like a line would best represent this data, maybe a quadratic, a cubic, and you decide. Once you decide that, that's what lets you choose which of these options you want. You can do linear regression, quadratic, cubic, quartic. That's it. You don't know anything about the rest of them yet. And this one in particular says it seems to follow a linear pattern, so write an equation for a linear representation. So I would choose number 4 and hit enter. When you do that, it automatically defaults list 1, list 2. Okay, if you want to go any further than, like if you have stuff in list 3, that's when you can say, okay, well, I want it to be list 1 is my X and list 3 is my Y, if you had just input it in different places. But if you did list 1, list 2, you don't even have to put that. Hit enter. This is see my equation, AX plus B. Here's my A and here's my B. So 0.56X plus 32.46. And that's your equation. And then you're just going to use that equation to answer the questions. Yeah. Okay, so on 17, let's go back to the equations that you had. So tell me what equations you got for 17. Well, you got them in you got them in 15. What were your 2 equations? All right, so when you figured whenever you calculated your linear regressions on your calculator, this should be what you got on number 15. There is the female equation, there's the male equation. So it says, when will the percentage of women and men be the same? So what we want to do is we want to say, okay, well, when will this equation equal this equation? So set them equal. 0.567x plus 32.45. Again, this came straight from your calculator. When will it equal? What do you mean? So x is defined as being the number of years past 1954. So let's go ahead and solve it. So plus 0.2436x. That would give me 8106. I'm going to go ahead and move this one over too while I'm here. 83,218 minus 32.45, 50.768. Divide by, I got 62. Didn't you tell me you got 100? Okay. So about 62.6. What that means is it will take 62 years for the men and women to have the same number of whatever it is, or be at the same percentage of employment. Then it says, what is that number? Well, you can plug this into either equation to find that, because this is when they're the same. It should give you the same thing. So what I want to know is y equals, what does y equal when x is 62.6? So you're just going to take that same equation, and I'm going to plug the 62 in for x here. Let's see. Yes, yes. That percentage, so 63 years later, they will both have the same percentage, and that percentage will be 68%. All right, we're going to switch gears here a little bit, and we're going to finish this section out real quick. Because half of you have just been staring blankly at me or somewhere else. But we got a few minutes to finish up. So I'll extend that homework from last night. I'm sure you finished it by now, but I'll extend it. And tonight's will be due tomorrow when you come in. All right, y'all ready? We're going to do this graphically, so you need your calculator again. I told y'all this was going to be like an extension of Algebra 2. We take things that we did in Algebra 2 and we really start doing a lot more with them. All right, we're going to talk about two ways to solve equations first. We're going to talk about algebraic solving, and then we'll talk about solve by graphing. Algebraic is what you are most used to. I'm not going to spend a long time on that, but you will have some kind of crazy equations that you're going to need to solve. Remember, what I'm doing is I'm solving algebraically. I'm going tab map. I'm trying to gather all my x's and variables together, get it by itself, see what I can do. And sometimes that's harder than what it seems like. But we have, this is if we're linear. If we're quadratic or bigger, it may involve factoring. It may involve the quadratic formula. All those are going to come back into play here in pre-cal as we start solving equations. So let's look at one. This is actually number 34 from your homework. I'm going to try to do examples that are coming from your homework to lessen that a little bit. How might I solve something that looks like this if I'm talking about algebraically? So I'm not graphing, I'm not using my calculator, I'm just set it equal to 0. Okay, so if I set it equal to 0, I can move this out. I got x, 2x minus 1 minus 10 equals 0. What now? Okay, so I need to clean it up a bit, right? I need to expand what I can and then condense it down some. So if I distribute that x, I get 2x squared minus x minus 10 equals 0. Any thoughts now on what I should do? Factor. When in doubt, factor. That's still a thing. How do I factor something that looks like this? I hope y'all remember how to factor. This is painful today, y'all. Y'all are not talking to me. You are staring at me like I'm crazy. Do what? It has to multiply to negative 10x squared, but add to negative 1x. What are the two factors? I heard negative 5 and 2, but that doesn't add negative 1. It's got to multiply to negative 10. Negative 20, I'm sorry. Okay, go ahead, negative 5 and 1. What would happen if I was at this point and I couldn't find those two numbers? Like, had that been 10 and I couldn't find those two numbers, what then would I do? Quadratic formula will always work. Another method? Complete the square. Y'all remember all that? All that's going to come back, so you might need to refresh some on that. Y'all are killing me, Smalls. Killing me. All right, 2x squared minus 5x squared. What? Oh, yes, sorry. Y'all are making me nervous. Really, really, really nervous right now. I don't know. It's so awkward in here. It's been awkward in here since a little bit ago when Percy was in here. All right, slash it. What's the GCF of the first two? GCF, what's left? I'm sorry. 2x minus 5. GCF of the last two? 2, what's left? So I have 2x minus 5, x plus 2. What are my two solutions? Set each of those equal to 0 and solve them, right? Just understand that it may or may not work out so nicely that you can factor it that way. Do y'all remember your quadratic formula? Do I need to write it down for you? Write it down for you. Is that what somebody said? Y'all are mumbling. Y'all are in here throwing muffins and whatnot before lunch, and now opposite b plus minus square root of b squared minus 4ac all over 2a. Always works. What if it's harder than this, though? What if it's not a quadratic? What if it's not something I can factor? What if, in fact, it's something that looks like this? How do you solve that? Any ideas, suggestions? Nothing. Crickets. I could. Well, the absolute values are what's going to throw me, but that's a good thought. No. And the point that I'm getting to here is it's really, really hard algebraically. When you're solving an absolute value equation, you have to set it equal to this, then you have to set it equal to the negative, and then I'm going to have to get into some. But graphically, I might be able to do something else. So 2 ways to solve graphically. And we talked about this in Algebra 2, so I hope you remember some. How do you solve equations graphically? Find the zeros. You're exactly right. The first way would be to make it equal 0 and find the x-intercepts. That can be done on my calculator very, very, very easily. There's a second way I could solve it when it looks like this. Do y'all know what that is? I could also graph each side of the equation separately and find where they intersect, and that would give me the solution also. So whichever you prefer, graph each side separately. Carter, how are you? You're not even writing this down. I don't have guided notes anymore. I'm going to stick with this first way just because y'all are so used to finding zeros already. I think it'll be a little easier for you. So it doesn't matter which one you move whichever one you want. I'm just going to move this one over here. So I'm going to have 0 equals 2 times the square root of x plus 8 minus the absolute value of 3x. So to your calculator we go. Everything goes in y equals. I'm going to go ahead and cut these plots off. I don't want them to mess me up. I have 2 times the square root of x plus 8 minus, do y'all know how to put the absolute value in here? You hit that button that says math, scroll over 1 to num, and see that very first one that says ABS? That's absolute value. That says take the absolute value of what's to follow. 3x minus 2. Yep, I'll wait on you. Math over to num, and it's the very first one, ABS. So math, right, enter. I'm going to do a zoom 6 here. Let that be a starting point for me. And I can definitely probably see everything going on. We know what an absolute value graph looks like, right? How am I going to find these solutions, though? Do you remember how to do that from Algebra 2? I don't want to use trace because it's not exact. Second trace lets me choose these calculations. Okay, what is that called? What's the x-intercept called? What's another word for x-intercept? 0. So I'm going to choose 0, which is number 2. You don't know where we are? So in the notes, is that what you said? This is actually number 40 in your homework. We're solving this. Did you put this in the equation? You put the equation in. Hit zoom 6. Now hit, you what? Did you subtract the absolute value? Yours look like this? Make sure your plots are off before you try to graph it. Right here. It's the square, 2 times the square root of x plus 8 minus the absolute value of 3x minus 3. I just moved everything to one side of that equation and that's what I'm graphing. Yeah.
Did I not put it?
World? Noah, did you write your calculator? I'll clear it out. I just literally cleared it for it. All right. Let me make sure I show you before you leave, because this is what you'll have to do tonight, how to find these zeros here. You do, but I don't know what it is. I'll have to look at yours after and see if I can find where it is. I don't remember where it is, though. You have a math function on there somewhere that calls up those, but I can't quite remember. Okay. Only a few minutes, that's right. Let's hit graph. All right, second trace, 0, right? We did this in Algebra 2. Okay, so you might have to dust the cobwebs off, but you should know how to do it. Left bound, remember, see my spider that's blinking? Go close to where it is, and you want to click left 1, 2, 3 times and hit enter. Second trace, 0. Zoom 6. All right, now it says right bound. Take your spider back close. It doesn't have to be exact, close to the place you're trying to find, and go right. 1, 2, 3, enter. Do you want me to guess? Well, that's the whole reason I did this, so hit enter one more time. One solution is negative 1.086. That is one answer to this equation. There are 2 answers. Yours says what? Left, get your spider on as close to this as you can and click left 3 times and enter. I'm going to do the same thing for the other 0. I'm going to get it as close as I can to the 0, right? That looks pretty close. And I'm going to hit the left button 1, 2, 3 times, enter. Take it back and then write 1, 2, 3, enter, and enter one last time tells it to guess. So my second solution for this one is 2.864. There are 2 solutions because there are 2 answers. Okay, it crosses 2. I can't remember now.
Oh.
Okay.
Got it.
You didn't cross back over. Hang on just a second and I'll help you. You're going to have tonight, it's already posted, but you're going to have 29 to 45 odd.
We do this on every problem.
Only on the last set. The first set is all algebraic. The second set's all graphic.